Yes, ma'am.
Yeah, okay. So, and what about the assignments? Like how you are solving it? You have deadline for that, right? To solve the assignments and submit. So what we will do, we will also discuss same way, like how the same assignment problems will be same kind. And I included some of the questions from the assignment, not all that you have to solve. So by today 1 hour, like how much I can teach that I will do it. And I think last class I shared the PPT. I hope all you got it right, like the problem sessions and all. Can anyone update that? Are you getting it or not?
No, ma'am.
Okay, so whatever we are sharing, you are not getting then. Are you saying like that or? We will wait 2 more minutes and we'll start the session. So you're able to see the PPT, right?
Yes, ma'am.
Yeah. So we will start today. Okay. So could you, like what last class me and Pavan like both TA. So we discussed like how the questions will be. So we gave some example for that, and he showed the syllabus and all part of it and all. So today we will start with the problem session itself to how the problem will be in your exams and assignments and all. Okay. So we will go to the first problem. First problem is, what is the change in internal energy of the system which does 4.5 times 10 to the power 5 joule of of work, while 3 times 10 to the power 6 joule of heat transfer occur into the system and 8 times 10 to the power 6 joule of heat transfer occur to the environment. So you have to find the what is the change in the internal energy of the system. So for doing this problem, what you have to know first, what is the like here what is given, work is given, you have to find the internal energy and total energy of the system also you can calculate from this. So these three quantities are given, you have to find the change in internal energy. So which law of thermodynamics deals with this, that we have to get first. So thermodynamic law of means first law of thermodynamics only dealing with this. So you have to solve this problem with first law of thermodynamics. Now we will solve it first. I will give an idea how to solve it. So what is first law of thermodynamics? Like according to first law, delta U will be Q minus W, right? Where Q means what? Q is the heat entering the system. Okay, so heat entering the system. Now what we have to do, first we have to find the total heat transfer. Okay, so Q you can write like, here the energies are 2, like 3 times 10 to the power 6 of heat transferred occur into the system, and 8 times 10 to the power 6 joule of heat occur into the environment. Okay, so you have to get 3 times 10 to the power 6 minus 8 times 10 to the power 6. So this will be the Q value here, which means this is heat enter, but here means total heat you have to take. So heat entering the system, and this one will be heat leaving the system. Okay, so this total in the bracket, total will give the total heat of the system. So now what you have to do, total heat minus work done. Work done it's already given 4.5 times 10 to the power 5. So now you have to solve this one and get the answer minus 5.45. It will be the digit value to the power 10 to the power 6 joule. So here negative sign shows that system has lost the internal energy, because work done by the system, it is more than that heat that enter into the system. That's why the answer is negative here. So this is the one of the example actually for this in this course, this kind of problem. It's the first how to calculate the internal energy. So once if you go through this problem once again, like what is the change in internal energy of the system which does 4.5 times 10 to the power joule of work, while 3 times 10 to the power 6 joule of heat transfer occur into the system, and 8 times 10 to the power joule of heat transfer occur to the environment. So here there are two heat values. One is heat transfer occur into the system, and another one is heat transfer occurs into the environment. So into the system also, out of the system also, heat transferring is happening. So we have to find first the total amount of heat in that system. That is the one thing. And another one, work is given. So you have to find the internal energy. So changing the internal energy, the formula will be from the first law of thermodynamics. It will be delta U is equal to Q minus W. Okay, now we have to find what is Q value. Q value is the total heat value. It will be 3 times 10 to the power 6 minus 8 times 10 to the power 6. That will be the total heat value. You will get it. After that, what you have to give, for you have to subtract the work done from that. That is 4.5 times 10 to the power 5. Then you will get the answer. You have to use the calculator and do the problems, and you will get the answer minus 5.45 times 10 to the power 6 joule. Okay. And what is the negative sign significant? It is showing the system has lost the internal energy. So this is the first problem for today's section. Okay. Now we will go to the second problem. Now in the second problem, what you have to do? The question is, anyone asked out? Yeah, there is one doubt actually. What is the negative? What is significant for negative sign of the net heat? It is showing that system has lost the internal energy. That is the value means meaning of that negative sign, which means that the work done by it is more than that of heat that enter into the system. That is the thing which is in that problem. Okay. Okay. Now we go to the second problem. In that second problem, the question is a car tire contains 0.0380 meter cube of air at the pressure of 2.20 times 10 to the power 5 Newton per meter square. How much more internal energy does this gas have than the same volume has at zero gauge pressure, which is equivalent to the normal atmosphere pressure? Okay. So how to solve this? So before solving this, what are they given? Its volume given and pressure is given. So using so with that values we have to solve the problem. So first what we have to do is, okay, first one we know that P1V pressure one. But there are two different pressure, right? Pressure is one is 2.20, another one is zero gauge pressure, which means normal atmospheric pressure. So P1 will be, we can write it as N1 R2. From that we can get the N1 value. It will be P1V divided by R2. Okay. Now next one we can get P2V will be N2RT. Then from that you will get N2 is equal to P2V divided by RT. Okay. And the formula for the internal energy, it will be 3 by 2 nRT. So if you take two pressure, means two values are for N1 and N2, you can take U1 divided by U2 for that. Okay, it will be N1 divided by N2, which implies the value from this formula, it will be P1 divided by P2. From that, and if you are taking u1 as a 3 by means u2 as a 3 by 2 n2 rt, then your v2 u2 will be 3 by 2 n2 rt, that you can replace from here. Then it will be 3 by 2 p2v divided by rt times rt. Okay, that will be become 3 by 2 times p2v. Now what you have to do, give, you have to give the values here. So 3 by 2 means 1.5 times P2 is what? P2 is zero gauge pressure. It will be 1.013. It's normal atmospheric pressure. It will be 10 to the power 5 Newton per meter square. I'm not writing the unit now here. Then you have to multiply with 0.0380. That is the volume. Okay. So the answer will be 5.77 times 10 to the power 3 joule. Okay, so that is the in U2, the internal energy. One means there will be U1 and U2 according to the pressure is changing. So the N1 and N2 number of moles value will be also will change. So N1 and N2 will change. So for N2 we found the value of U2 now. Okay. from that earlier case, you found that U2 will be 5.77 times 10 to the power 3 joule. Now what we have to do, you have to calculate the U1 also. So U1 will be P1 divided by P2 times U2. Okay, it will be 2.20 times 10 to the power 5 divided by 1.03013 times 10 to the power 5 times U2 will be 5.77 times 10 to the power 3. Okay, the answer will be for this 1.25 times 10 to the power 4 joule. Now we have to know how much heat, additional heat needed. So it will be U1 minus U2, that will be 6.77 times 10 to the power 3 joule. So this is the way you have to solve the problem. Okay, so we will go through this problem once again. The problem is a car tire contains 0.0380 meter cube of air at the pressure of 2.20 times 10 to the power 5 Newton per meter square. How much the more internal energy does this gas have than the same volume has to zero gauge pressure? Okay, now here you have to find the how much more internal energy needed. It reaches to a normal atmospheric pressure. So that is the question. So there will be a internal energy value for the pressure 2.20 times 10 to the power 5. Similarly, there will be internal value and internal energy value for the pressure, normal atmospheric pressure also. Okay, so we can take it as U2 and U1. Similarly, there will be pressure is changing, so P1 and P2, and N will change, that N1 and N2. And we know the formula, so P1V is equal to N1RT here. Then from that N1 we can find it. Similarly, P2V is equal to N2RT. From that N2 we can find it, that is P2V divided by RT. Okay, now we know the internal energy formula, it will be 3 by 2 nRT. From that we can take the ratio, we will get the idea of this. That will be U1 divided by U2, that will equal to N1 divided by N2, which implies P1 divided by P2 from here. Okay, now our UT will be what? 3 by 2 N2 RT. So we are giving that 3 by 2 N2 RT. In the place of N2, we can give it as here P2V divided by RT. We are giving that and substituting the numbers and getting the answer 5.77 times 10 to the power 3 joule. Okay, so that is U2 value, and U1 value will be, we can easily find from here. Just do this. So U1 will be P1 divided by P2 times U2. Then you will get the answer 1.25 times 10 to the power 4 joule. And here we have to find the change in energy. So U1 minus U2, that will be 6.77 times 10 to the power 3 joule. So this is the second problem for today's class. So everyone, please go through this problem.
What's that?
Hello.
Yeah.
So the participants, do you have any queries regarding this question?
No, sir.
So the participants, like as sure as arrived to this question answer of this question. So such kind of option you will be getting in your assignment or the end exam which you will be facing. So that one, like 6.77 into 10 raised to 3 joule. So it will be one of the options out of the four options. So we will try, like we have the way the assignments has been designed, they are so that you will be getting one of the options there uh, as the right option, and you have to opt for the correct option, then you'll be getting the marks for that one. So if anyone is not having any query, then Aishwarya, shall we move to the next question?
Yeah, like one more doubt in the chat box. Actually, it's not regarding the class. It's asking like uh, we, we can write two exam at a time in a same timing. Like I don't know
Uh,
that.
Two exams.
Yeah,
Like the person is asking regarding the two separate NPTEL courses, or
that I too don't know. Like Durgam, if he is present here, he can raise the questions once again.
okay. Yeah, please
Yeah, he's
tell.
giving chat actually.
Yeah. So another thing regarding the assignment is that before the deadline of the assignment, you can submit the assignment as many times as you want to submit. So such kind of things are there.
Okay,
As a,
resubmission is allowed then.
yeah, the submission is allowed. So
He's
before the
asking
deadline,
questions. Can you check the chat box?
just a minute. Like we can write two exams at a time. You're saying about the two NPTEL courses? Are you saying about the two separate NPTEL courses? Actually, for that particular thing, it's a kind of query which we will not be able to address. So please contact the NPTEL regarding this. They will be in a better position to help you. Okay. Thank you.
Yeah. So shall we move to the next problem, like third problems of today's section?
Yes, sure.
So this problem contain the efficiency part. Okay. So problem is there are two sessions. First one is what is the efficiency of a cyclical heat engine in which 75 kilojoule of heat transfer occurred to the environment for every 95 kilojoule of heat transfer into the engine. And B question is how much work does it produce for 100 kilojoule of heat transfer into the engine. Okay, so there is two questions are there. First we will go to the first one. Okay, for answering A, we have to define two quantity. One is QH. QH is the heat absorbed from the hot object. Okay, and another one is QC. QC will be heat given out of the cold object. And this QC normally will be the environment. Okay. So these are the two quantity. Now what is the question? What is the efficiency, right? So here we can define like work as work done will be QH minus QC. Now if we go to the first problem answer, efficiency will be work divided by QH, which means work divided by heat absorbed from the hot object. So what will be the work here? Work is QH minus QC. That is the work done by the system, and you have to divide it with QH. That you can write it as 1 minus QC divided by QH, and substitute the value here. 1 minus QC is what? Heat given to the environment. So heat transfer to the environment is 75 kilojoule. Okay, divided by heat absorbed, it is 95. You have to find the answer. It will be 0.211, or you can write it as 21 percentage. 21.1 percentage. Okay, so this is the first question answer, the efficiency of that system. Now, if we go to the second question, how much work does it produce the heat transfer to the engine? Okay, so we know that efficiency formula is W divided by QH. So here you have to find the W value. It will be QH times efficiency, right? The efficiency of the system already we found it. So it will be 0.21. So 0.211 times 100 kilojoule. So the answer will be 21.1 kilojoule of work. And for solving problem in the case of efficiency, you have to take the digital value. You no need to take the, you should not take the percentage value. Always it should be digit. Okay, it should, normally it will be between 0 to 1. So this is the answer for the question number 3. So we will go to the question number 3 once again to revise it. So, what is the efficiency of a cyclical heat engine in which 75 kilojoule of heat transfer occur to the environment for every 95 kilojoule of heat transfer into the engine? And second question, how much work does it produce of 100 kilojoule of heat transfer into the engine? So here we have the heat transfer is given. You have to calculate the efficiency and work of the system. So for calculating that, first we have to define the what is the heat absorbed and heat is given to the system. So QH you can write a heat absorbed from the hot object, and QC you can write it a heat given out of the cold object, that is normally will be environment. Okay, now what will be the work will be QH minus QC. What is the heat absorbed subtracted by the environment? Okay, now efficiency formula we know already, it's general known formula in thermodynamics, W work divided by QH. So it will be QH minus QC divided by QH. You can write it as 1 minus QC divided by QH. It will be 1 minus 75 divided by 95, because 75 95 in same unit, okay, kilojoule. That's why we can, other if it is in both are different unit, you have to convert the unit as per the rule. Okay. Now just do the calculation, you will get the answer 0.21. Normally efficiency we can name terms in a normal digital point as well as the percentage. So here 0.21, that will be 21 percentage. Now the second part of this question, it is how much work does it produce for 100 kilojoule of heat transfer into the engine. So here we have to calculate the work. So efficiency of the system we already found. So if you know the efficiency and the heat absorbed, then we can easily found the value of work done. It will be QH times the efficiency. So the answer will be 0.211 times 100 kilojoule. That will be 21.1 kilojoule. So the unit is kilojoule. So for your assignment and everything, you have to carefully see what is the unit, what are the digit. These answers will be in your options. So you have to clearly select it. Okay. Do anyone have doubt in this problem?
Hello, ma'am.
Yeah.
Hello. In question, if a mechanical loss is given, then should we have to consider in QC or not?
What? Can you please say loudly? I cannot hear what you're saying.
If mechanical loss is given in question, then should we have to consider in QC or not?
If force is given, you are asking.
What means?
What you are asking? What is given into the system?
If mechanical frictional loss is given in question that frictional loss is X
No,
joule,
then you
then
cannot directly find like this. You have to. This is this is like an ideal case, right? If the heat's given to the system and he approaches the system. If some extra force or friction is there, you cannot find this is easily. Okay.
okay.
Hello, Mr. Parmar.
Yes, sir.
The mechanical losses are finally accounted as heat loss only, but you will not be getting any data as quoted as mechanical loss. After all, the heat loss is uh, calculated in an engine by heat rejected to the water jacket or any cooling system which is given that there to cool the engine in practical applications. So separately you will not be getting any mechanical loss data.
Such cases
Yes,
efficiency will
sir.
be different, right? Like you have
Yes,
reduced them.
certainly efficiency will be different.
It also including heat transfer. Is it?
Sorry, your voice is not clear. You can type your question in chat box.
Okay, okay. I have write it in chat box.
Yes, frictional losses are finally converted into any loss which means finally converted into heat loss only. There is no measurement of friction loss. Finally, that friction
Okay.
produces heat. So whatever input you are giving to engine, a part of that is going to be rejected as heat due to thermodynamic limitation, and part of that will be rejected as friction loss, that is because of mechanical limitations.
Okay, got it, sir. Thank you.
Yes, thank you. Aishwarya, please go on.
Yeah, sure. Okay. Now, here the questions related to coefficient of performance. So earlier question we discussed that efficiency of the system, and here what is the coefficient of performance? First we should know that. So coefficient of performance is 1 over the efficiency, which means reciprocal of the efficiency. Coefficient of performance of a heat pump, it will be different. For heat pump it will be different, and for refrigerator it will be different, the performance. Okay, so for heat pump means what, which we use into the winter, like to heat up the home. That is the main use of heat pump, like increase the heat. Okay, so that is the heat pump. And another one is we are using as in is refrigerator. Okay, so we can call it as a coefficient of performance. That coefficient of performance is not the same for both heat engine as well as the refrigerator. So the reason is that a refrigerator is actually a Carnot engine. Okay, and which is work in the reverse order, but heat pump or heat engine is completely work in the completely different from the Carnot engine. So heat is added into the system, it just distribute to the heat. Okay, in such case of heat pump you can write like coefficient of performance for the heat pump, it will be TH divided by TH minus TC. Okay, the temperature of the hot and temperature of the cold part. So that you can write here, you can write, you have to convert this all into the Kelvin scale. Then you can write 313 Kelvin divided by 313 minus 248. That answer will be 4.82. So it is more than 1 actually. Okay, so that is the answer for this question. It's a simple question, but you have to know what is the coefficient of performance. That is the important thing. Like efficiency formula will be same for all the systems, like we can calculate it from if you know the heat and work. But in the case of coefficient of performance, by the temperature you have to each system it will be different, because it's depending on the like order, it is reversible or irreversible, like that, which is the Carnot cycle, or it depends on that. So that's why for a heat engine or heat pump, the coefficient of performance will be TH divided by TH minus TC, that you can write as 1 minus TH by TC and do the calculation. And every time you have to remember one thing, if you are converting every time for solving a problem in the temperature case, you have to convert that into Kelvin and do the problems. Okay, that is more important thing. Then we will go to the next problem. That problem also related to the coefficient of performance. Okay, so it is in some different way. So suppose you want to operate an ideal refrigerator with a cold temperature of minus 10 degrees Celsius, and you would like to have a coefficient of performance 7. What is the hot reservoir temperature for such refrigerator? So you know that coefficient of performance like you can calculate through the temperature. Okay, so here what is the, you have, for that formula you need cold temperature and the temperature of heat part. Okay, and I told that for heat pump case and refrigerator case, both will be, equation will be different. So in the case of refrigerator, we can write as coefficient of performance will be Tc divided by Th minus Tc. If you see the earlier problem, it will be Th divided by Th minus Tc. Here it will be Tc divided by Th minus Tc. Okay, and from that you have to find the reservoir temperature. Okay, hot reservoir temperature. So you have to calculate the Th value here. So finding Th value, what you have to do first? Th value, just do the mathematical part and you will get the Th value will be Tc divided by coefficient of performance plus Tc. Okay, so it will be, you have to convert minus 10 degrees Celsius to the Kelvin. It will be 263 divided by coefficient of performance. It's given that 7. So 7 plus 263 Kelvin. So your answer will be in the Kelvin, that will be 300.57 Kelvin. And you have to check your option. It is in Kelvin or it is in degrees Celsius. So you can convert it into, let's say, 27.6 degrees Celsius. And for a refrigerator, the hot reservoir means it is surrounding. Okay, it will be normally it is surrounding of the refrigerator, which means it will be in the room temperature of the system. Our room temperature will be the hot reservoir temperature of the hot reservoir in the case of refrigerator. So please go through these two questions, 4 and 5. So we are discussing coefficient of performance, and it's one for heat engine and one for refrigerator. And for heat engine, the formula will be Th divided by Th minus Tc, and for a refrigerator it will be Tc, cold temperature divided by the Th minus Tc. Okay.
Aishwarya,
Yeah.
please see your comment box.
Okay.
Few questions has been raised.
How can we manipulate atmospheric temperature? Like manipulating atmospheric temperature means what you mean?
Hello. Yeah. Yashpal, as far as your question is concerned, nobody, as far as nobody mentioned, nowhere mentioned regarding this that the room temperature, the atmospheric temperature will be manipulated or may be manipulated.
That is
So,
one thing, and they are saying like if we normally room temperature will not be constant, right?
mhm.
Accordingly, the coefficient of performance of the system will change it.
Yes, that is true. So it depends on the question. Like if the desirable thing is that, like, you want to get the desirable temperature minus 10 degrees Celsius. It may be that somebody is sitting in Rajasthan in the hot condition, and his surrounding temperature may be around, let's say, 40 degrees Celsius, and somebody sitting in, let's say, Jammu and Kashmir or Shimla, then they may have room temperature around 30 degree or 27 degree. So it's like that. So it's a question specific thing. So nothing to worry about. Nobody is going to manipulate the atmospheric temperature. And I think and the other thing which you are asking is that if we get 50 degrees Celsius as answer, then what happens? So it depends on the values which are given to you as the input values. Like COP will be there, some cold temperature will be there, and accordingly you will be getting the output answer. Like 50 degrees Celsius, if the other values are um, according to the desirable result as 50 degrees Celsius, then it is right. Otherwise, there may be some, calculation mistake or something like this. Second one is with the quality or quantity of heat. Okay, Mr. Prabhat Kumar. Okay, before I take this question of Prabhat Kumar, somebody was asking, I joined this course, Make 7 to Sanju. I joined this course late. I have burned out in practice assignment. With the permission, shall I raise? Okay, small shall. Yeah, please go on. Make MAG 7 to Sanju. And Prabhat Kumar, second law deals with the quality or quantity of heat. Yeah, second law deals with the quality of heat, because first law tells us about the quantity of heat, because it first law tells about, like, what is the heat input, what will be the work done, what will be the internal energy. So we get the quantification of the energy, and then the second law, it tells us about the direction in which the heat will be.
So
You
we
know,
can say it as both quality and quantity, right?
yeah, we can say so, but to be very specific, quality means second law is very well defining the quality, and yes, if it will also be taking care of the quantity. So make 7 to Sanju. Do you have any query, like, regarding this assignment? Are you typing? I hope, Prabhat, I hope you got your answer. Thank you. So it's better to go through the video lectures and the other material provided to you people, because uh, there is no such a specific book recommended by the professors for this particular course. So it's good that you can follow PK Nag or Sanjel Boyles or some other book, standard book, which will be helpful for you to practice the problems.
Problem is delivered from the heat supplies.
So let me introduce our another TA, Mr. Pulak Kumar Ray. He's also there. So Sanju, we have to go through that assignment. Actually, right now we are not uh, in a position to see that assignment. So I think there is a provision of sending the screenshots. Do we have such provision here in the comments? I don't
You
think
can
so.
share his screen if required.
Okay, okay. Sanju, if you have this query, then can you share your screen for this particular thing? I think the participants can share their screen or they can unmute themselves. You can unmute yourself and you can ask the question, Sanju. Sanju is talking about the assignment, practice assignment.
Okay,
Actually,
assignment problem number 2.
I think he's talking about maybe the assignment 0. Is it
The
so?
assignment he didn't say, right?
Yeah, yeah, yeah. Yes. Can you specify the assignment, or are you talking about the present assignment which Aishwarya is sharing with all of us? With the present one?
Calculating the KWH temperature.
The reservoir temperature.
Only the practice assignment.
Practice assignment, with practice assignment, you mean to say assignment 0? Okay.
Okay, assignment 0. Remember the time.
Okay, just a minute. You have to see that question. 0. In the meanwhile, if anyone is having any other query, he or she can write or speak about that problem. Okay, fine.
Okay, I can share actually.
Yeah, actually, no, Pulak has got it, and the question is, Aishwarya, did you get the same thing?
Yeah, let me
Share the screen, please share the screen then.
and he is
Assignment,
asking question about this, right?
yeah, assignment 0. Yes,
Yeah, I
yes.
think.
So 354, yeah, it is there. So his question is like the problem is calculating the kilowatt from the given heat supply and the reservoir temperature. Problem 2. Okay, please, if you can unmute yourself, then please ask the question. Otherwise, you can type the question. Please be quick. It's already 7 p.m.
Like, what he's asking, calculating the Heat, right? From the given heat supplies and the reservoir temperature. That's what you're asking.
Actually, he has to type what he's faced, the problem he is facing regarding this question.
Aishwarya, better you explain this question, whatever you have taken. So I think his doubt will be included in your explanation.
For explaining this question. Yeah, the question is a reversible heat engine operating between the source temperature of 800 degrees Celsius and the sink temperature of 50 degrees Celsius. If 500 kilojoule per second of heat is supplied, then what amount of heat ejected? You have to find the approximate value. Okay, so first as what I told, like temperature should be in Kelvin, just we converted the temperature into Kelvin, that we taken as T1 and T2, 50 and 800 degrees Celsius. Now T1 is the temperature for sink, okay, and that is 50 degrees Celsius one, and T2 is the temperature for source. So here the efficiency you can calculate, it will be 1 minus T1 divided by T2, that will be 1 minus Q1 divided by T2, Q2. From this 2 you can get it, the value of Q1 will be Q1 by divided by Q2 times T1 divided by T2 times Q2. Okay, from this we are not going through the value of efficiency, just from this formula we are getting that Q1 value. Then substitute the answers here, like the value of that, and multiply with the Q2 value, it's already given. 500 kilojoule is supplied to the system, then it will be 150 kilowatt. So that 150 kilo heat is supplied to the heat engine actually. I hope the doubt clear now.
Yes, he has typed yes. Thank you, ma'am, in that one.
So like there are some more things actually solved from the assignment 2 that we will discuss in next lecture, actually next week. I didn't get, like time is not sufficient actually to discuss that. So the problem part we discussed today, but theory questions whatever had in assignment 2, like that also I prepared